Hello and welcome everybody. My name is Todd Dufour and I'm with the Chicago Houdini Users Group, and today I'm going to be bringing you a presentation on what I think is one of the most overlooked and often underutilized tools in Houdini, the Metaball. Who am I? I'm currently the effects supervisor at the Mill Chicago. I have over 17 years of Houdini experience. I was the effects supervisor at Atomic Fiction Montreal, and before that, I've been a freelance and staff effects artist at ILM, the Mill LA, Mirada, Sony Imageworks, Asylum, and Digital Domain. I want to give some special thanks and a couple nod outs to Sean Faden, who was my first effects lead at Digital Domain. He used to say, if you're not using a Metaball, then you aren't trying. I also want to give a nod to Theo Vandernoot. Some of us used to call him affectionately the Mad Russian, although I don't think he's Russian. And he said, if you know how to code, then write and compile Vex. Lastly, I want to thank and give a nod to Stephen Marshall, who's one of the smartest guys I knew. And he always had the documentation open. So what are we going to be covering? First, I'm going to blast through the basics. Then we're going to pillage and plunder. And then we're going to advance the cause. So blasting through the basics, we're going to look at the fundamentals of metaballs. We're going to create some meta fields. We're going to turn those fields into polygons using the meta convert. We're going to take a look at the magnet SOP. Then we're going to look at metaball forces, specifically the metaball force SOP and the metaball force pop. After that, we're going to pillage and plunder. I'm going to give you a quick example of how you can use the meta weight function in Vex to get a density attribute quickly from a meta field. Then we're going to take a look at Ceci's own pop meta force, which has an elegant and beautiful implementation of a metaball loop. And we're going to take that and we're going to create two SOP HCAs, a mighty meta interpolate and a mighty meta deform. Then we're going to advance the cause, do some more advanced stuff. We're going to create a mighty meta gas force, including creating noisy velocities and creating noisy temperature sourcing from a specified range of force. So hold fast and let's get started. Hi everybody, and here we are in Houdini. I just want to let everybody know that I'm going to be recording this not pre-baked, but as if I was doing a tutorial. And then when the presentation is cut, I'll probably cut out all the long tutorial-like stuff and just get to the meat and potatoes. But let's get started. First of all, let's dive into the basics. And to start with the basics, let's lay down a geometry. And for now, we're going to call it a mighty metaball because I really love these guys. So what is a metaball? This is one of those things that people don't really look at that often, but if we look at it, it's just a blob. One of the great things about this blob is, like anything else in Houdini, you can move it around you can scale it, you can even rotate them. They do have full matrices and full transforms. If you notice, there's different models. Sometimes these are very useful, and it's just different ways of interpreting the fields. Think about them like gammas or logarithmic kind of ways of looking at things. I have an affinity for the RenderMan model. I'm gonna put all this stuff back to the defaults. And the other thing that it has is it has exponents, so you can make them. You can have a square metaball. Again, I'm going to go back to the defaults. So another thing that's really interesting about metaballs is that they will respect color. So you can see that they respect color. Typically when I use them, I leave them kind of at their center and I put down a transform handle so that I can move them around this way. So let's break off into this typical kind of RGB world that a lot of us use in life. So we'll put down 0 and 1 and copy paste, and we'll make a blue one and merge them all together. and you get a great big white blob. But as you can see, we can slowly move them out, and notice how they have a nice way of interpolating across each other. Now, of course, any of these things can be animated. The original Metaball can have its weight animated up and down. And notice, just kind of get a good idea of how all these different little shapes that can be made from this. So let's give another little example here of something that's kind of important. I'm going to lay down a grid and demonstrate something else, and I'm going to put a lot of points on this grid. Oh, actually, we'll do it this way. I'm going to scatter some points on this bad boy and make sure that we have P-scale on with the P-scale attribute. And like anything else, metaballs can be copied to points. And you notice, boom, boom, boom. Output scale radii, so we'll scale it up a little bit. Scale it up to 4. So now you see we get this great big crazy meta field. And again, it should absolutely respect the colors. So let's put some random colors on these guys, right? Let's make sure we got random. Random color, and make sure we copy to attributes. Boom, and look at that. We have a nice, crazy kind of colorful meta field. Now, if you notice that there's some orange circles around all the metaballs, that is the hull that is being turned on. I have that displayed, and I'll explain to you that in just a second. So I'm going to merge in another metaball. And this is kind of an interesting thing about metaballs, or the basics of them, is that metaballs can have a negative weight. So if we look at this metaball here, this metaball is right here in the center, it can have a negative weight. And if you notice, what happens is we start eating away at the other meta field. And it's also eating away the interpolation of the meta field. These are really interesting things to think about. You know, you can easily anywhere in here animate a hole in something. Boom. Yeah, so that's sort of cool. Now that we get a little feel for how to move around and get a feel for metaballs and just kind of how to interact with them, let's move on to I told you that we would convert this stuff to geometry. So let's just see how that gets done. So there is something called convert meta. And be very careful. I'm always a little hesitant about just plugging things in. You should always have a good idea before you do this of how big of a size you're going to stamp in before you do it. Otherwise, you could generate way too much geometry, just like voxels. So we'll take a look at this. This seems really big, so we probably could go a little small, a little small, a little small, a little small, something like that. And we'll plug this in and take a look. And you notice that this will help us kind of decide how big of a voxelization we're going to have of a meta surface. And again, this thing is completely able to update and pick up everything right from this meta field. So a good thing to know is how to use this meta convert. So with that, let's move on to the next thing, which will be setting up the magnet sop. Okay, let's dive into the magnet sop. So for this, I'm going to bring out the pig, which is one of my favorite test pieces of geometry. Convert him into polygons. And for this demonstration, I'm actually going to make some points from volumes out of him. We're going to pretend that we have one of those kind of standard problems where maybe we're flying in. Let's just make the geometry a little bit bigger. Pretend that we're flying into a field of particles, and we've got particles that are coming right into our face. You know what I mean? We'll actually generate a little bit more particles from that, so we can see a little bit better. So I'll give it 0.04. There's a lot. So imagine you're flying in, and they're coming right into screen, right before the clipping plane. So the magnet SOP comes. The magnet SOP is one of those things that we used all the time, especially when you're flying like crazy into a field. You can copy one of these things to your camera point. For now, I'm just going to pretend that the camera point is a metaball. And if we look, somewhere in here we'll make our little metaball, and we'll make them a little bit smaller, just the size of a camera relative to the size of the pig. Just imagine we're a little spaceship flying through here, right? And lock down the point scale a little bit again, and add a little bit of scale to this. And if you notice, what ends up happening is that if you were flying along, the particles would just kind of gently move their way out from around the camera, so they wouldn't fly right into the camera's field of view. And this is a great way of, instead of deleting them or scaling them down, to just kind of nudge them out of the way. And you can also nudge just about anything using this technique. Like if we just wanted to nudge back his ear a little bit, we could kind of come in here and just nudge things around. One of the great things about this also is, with this, is that the magnet SOP will respect rotation, so you could rotate around his ear. So all of a sudden you've got you can rotate around, make nice little swirly patterns and waves and all sorts of kind of interesting, maybe MoGraphy type of techniques. In fact, most of MoGraph is by using influencers, and a metaball is a great influencer. And again, remember, metaballs can be negative, so they can be used, like it said, magnet. Magnet, it can be used to, where are they? Remember, use this little guide to demonstrate where our metaball is. So let's make the force a little bit bigger. And this should help us kind of basically get rid of all the rotations. 0, 0, 0. Whoops. 0. You notice that this will suck the pig into a point. Let's suck him in. Let's pull him to a spot. Another great way of attracting and affecting things by ways in which you need to pull them around. So this is kind of one of the first uses that I had of the magnet SOP. There is another, and I'm going to start and stop this video again just to get this going. So here is another use that we have for the magnet SOP, which we used on Stealth for creating velocity fields for distorting a sky full of clouds. I'm going to pretend that I got a great big grid here. And we're just going to pretend that this is all at scale, even though it's not. And I'm going to scatter a bunch of points on it. Probably double that. 1, 2, 3, 4. And set up a very standard, I like using rest. Rest. And then we'll put down a little transform SOP to test this before we get too far along. Very sticky day. Okay, so we're going to do vector my PTB equals 0.1 PT num. And then v is going to equal at rest minus my PTB. And let's see if we can see that. Visualize. I either do this right or I do this wrong every time. Let's see. And so we're going to visualize V, V, marker, and V, and make that a vector. And looks like I did it wrong. I always seem to get this backwards. Think I would remember it, but it's always so easy just to flip it around that. There we go. So there we go. That's the velocity going. Okay. So instead of using this transform SOP, magnet, tab, magnet, and this is a big concept on what we're going to be doing later in the tutorial, later in the presentation, is that the great thing about a magnet SOP. So we'll take this and we're just gonna, I'm just gonna rotate things a little bit, right? So let's rotate it a few degrees and take a look at what our visualization's doing, right? This is one of the great things about Metaballs when it comes to generating forces. And if we look, we can take a radius and get a bigger swirl. Of course, move them around. Take another one, copy and paste it, and merge it in. And bink, merge it in. And of course, like I said before, T, you can always have a negative value, so it'll twirl in the opposite direction. If you also look at a magnet SOP, we could, well, I'm going to get rid of the rotations for now and show you a little bit of what it looks like to just blow things up, you know, boom, boom, blow things up. So this is kind of one of the reasons why I've always been a real big fan of Metaballs, is their ability to quickly and easily be able to visualize an area that I want to affect, have lots of controls over scale, weight, rotations. All of these, of course, are keyframeable and easy to visualize when you keyframe it. And really quick, fast feedback. So I think that's about as much as I want to cover with the magnet SOP. Again, I'll give you one more little look here and blow something up again. We'll make both of these, you know, like you can go concussion and then blow out, which is always kind of cool. Suck in and boom. Hopefully you guys are following along with this and it's making some sense. Okay, now that we've looked at what the magnet SOP can do, let's have a little bit more concrete example of using Metaballs. One of my favorite tutorial artists is Stephen Nipping, and I'm going to kind of do a very brief example of something that he used a metaball in one of his tutorials using doing applied ridges, which is a great tutorial if you get a chance to look at it. So let's take a look at using a metaball as a force to blow up a building. So we're going to call this Metaforce. We're going to dive in. I'm going to build a quick building. This building is going to be really kind of a lazy man's building, so we're just going to go up. We'll kind of move this out, move this out, move this out. Poly extrude out the edges a little bit, something like that. Put down a grid. This grid's got to be pretty big. Okay, yeah, I'm gonna make this grid a little bit bigger. All right. So my building is a little bit bigger than I want it to be. So we're just gonna make this a little bit smaller. A little bit smaller. Our walls are pretty thick. Maybe my walls are a little bit too thick. So make sure that we're gonna now put the back on the wall so we have a nice solid walls like that. Put down a Boolean. Be careful not to grab the Boolean fracture. And if we do this, we should have a nice little kind of solid set of walls. We're going to use an RBD material fracture in a second, but before we do that, we're just going to make sure we triangulate all the geometry because that'll make the RBD material fracture a little bit happier. Always takes a second or two for this guy to be laid down. A little bit of patience. All right, here we go. And this thing will fracture it up. And if we look, we have some things fractured here. For the sake of our demonstration, I'm going to really crank up the amount of pieces I'm fracturing by. Wait again here a little bit. I'm on an older Mac, so it's a little bit slow. Going to put down an RCD configure. And one of the things I want to do is I want to make sure, shift click these three guys, click. I want to make sure, this guy always seems to be go down with a red flag. I just middle click on it and that seems to make it go away. So in configuring this, one of the things I want to have happen is I want to make sure that the bottom set of pieces don't end up colliding with the ground and generating some shock, generating a collision impact. So first thing I'm going to do is make sure everything's active. I'm going to click here on this little plus and go to the second page, and I'm going to make sure that's inactive, and I'm going to make anything that is less than, any Y position that is less than 2 is going to be inactive. And so we can see that by here. We're going to put down constraints. I'll show you in a second. There are the constraints. And copy and paste this over and call this proxy, which will be the proxy geometry we use the sim with. That's a proxy geometry, and put down a little blast node to check things. Half of the job is always checking to make sure what we think is working is working. So at active equals 1. And if we, that's a point group. Oh, yeah. Delete non-selected. That's everything. So let's just make sure I did this right. At P less than 2, less than 10. So anything that is less than at P dot Y, maybe it's that I have spaces in here. Sometimes it can be as simple as that. Yeah, it doesn't like spaces. Okay, my bad. So make sure there are no spaces in there. So this will be our foundation of pieces that are going to be used to kind of hold the building to the ground. So always save early, save often. We're going to put down our dot network and go sim and dive in here. Put down our RCD packed geometry. Some people use the inputs. I kind of an old school and I just kind of dig up like this by using so there's our geometry. We'll put down a rigid body solver, plug this into this, get a sim going by using a little bit of gravity. I'm working at a little bit of a strange scale, so I'm just going to put my gravity at 100, put down a ground plane, merge this guy into this guy, this guy, and this guy. Make sure we display that. We'll make this 40 by 40, just so that we, let's make it 60 by 60. Something so we can see definitely some ground. And if we hit play at this point, let's save this up again, M right dash B, if I back up, his click, click, and hit play, we should see our building just kind of fall. And that's what's expected. So everything's working good. Good time to save again. So let's get our constraints in. Getting our constraints in is easy. Constraint network. Plug this bad boy into there. He's going to complain. That's because he's going to want a constraint glue relationship, and plug this in. Now, for whatever reason, this needs to be set to glue. Well, it's not for any reason. We'll show you why. Glue constraint relationship. And if we turn this off, display, we should have seen our constraints. Oh, I know why we didn't see our constraints, because we never pointed to them. So same thing with this, dot dot slash, and dot dot slash, and we should go to constraints. Now we'll check. Okay, dokie. So turn that off. There are constraints. So this is very important. Now we change to glue. We're going to go up and we'll look at our constraints. Right click and go to spreadsheet. And you'll see constraint name is glue. That has to match with this. So very important. Now if we run this in, we'll see that our building just kind of sits there and does nothing, which is what we're expecting. So save again. We did something that was valuable and useful. So let's get into the Metaball force, right? Here comes Metaball for blowing this guy up. So we're going to go back to where we have our building right here, turn on our Metaball, and we're going to place this Metaball, and let's just say we're going to blow up this, we're going to have a bomb go off in this front right corner. So we're going to take this Metaball and we'll scale them up, move them up, T, move them up into kind of position here, maybe scale them this way a little bit. That's a pretty good bomb. We'll just put that right there. Okay, so this is what is really great, using this force. So we're going to drag this force in here, and radial force. Now if we look at this, there's always a good way of remembering. The force wants to suck in radially, so if we want to blow it up, we got to go negative on it, right? And like always, we're going to put down a null stop and give this a name so that we can get it. Meta force, and we'll go into our sim. Make sure I'm on 1 so we don't do a bunch of cooking. And well, actually, we're going to do one thing before. Well, now we'll go in there. And we're going to put in pop Metaball force. Now this node is really great. I use this node for, well, let's not forget this first, right? Getting ahead of ourselves a bit. And let's go get our Metaball force. There it is. And if we see it, there it is. It shows up in the guide, which is great. But this SOP is great. I use this pop all the time as a way of figuring out how to use Metaballs when I write my own vex. And if we dive in, I'll do that dive again. Allow editing of contents on the Metaball force. Dive into the pop, and right here, compute meta force. This is a great bunch of code that you can always look back to, and we will in a later video, a later section. We'll dive in and steal this code when we do pillage and plunder to write a Metaball deformer, and to also write a Metaball gas force. So let's go up. We'll match current def because we don't want to break anything. Match current definition. So one thing I do quite often when I'm experimenting with things is I use powers of 10 to try to figure out how much force I need on something. So let's use a crazy amount of force and see what happens here. Okay, and we'll save since we've done enough little bit of work. And nothing happened. So that's a little bit of a surprise. And one other thing we want to think about, we're trying to make a little impact explosion. So even though nothing happened, I'll explain that in a second. We want to make sure that this Metaball only generates force for 1 frame. So we're going to do that by doing something like this. $F equals 4, which is one of my lucky numbers. My last name is Dufour. And if we look, we should be able to look here and go 1, 2, 3, boom, it's on, then it's off. So rewind to 1, go back into our top SOP. So one of the reasons why this isn't blowing up is because of all these constraints. These constraints are holding everything together. And in order to get the constraints and some of the objects moving, we're going to have to get rid of some of these initial constraints. So in order to do that, we're going to put down a SOP solver and plug it in here to constraint solvers. We're going to dive in here, look at the relationship geometry, which will bring in the constraints. Maybe if we click 1 frame, there are the constraints. And we know we want to blow up on frame 4, so we'll just go to frame 4 for now, and we're going to go a little bit off, and here's a little thread. We're going to go get our Metaball, so object merge. Now we're pretty deep into this SOP solver, so I // go up a directory, // go up another directory, // now I'm waiting to see, oh, there it is, Metaball force. We're going to select that, and we should see it right there. This is the frame 4, where it turns on. For the sake of this, and I usually write this in Vex, but it's a little bit easier to do this with a point VOP, and I know it's a little angry. That's all right. Houdini likes being angry. So meta weight, Metaball weight is the function we're looking for. We're going to use the second input, plug it in there, plug this in here, and tab bind export, and we're going to export our weight, W-E-I-G-H-T. And if you notice right away, we see this color. Now I had already set up a visualizer, but In order to set up a visualizer, if we click on this eye and click on weight, well, a little bit sensitive, and click on weight, I didn't do it fast enough, click on weight, you notice it goes away. If I click back on weight, I see that visualization. It's that easy to kind of visualize what that is. Now, constraints are basically primitives, not points. So we're going to want to attribute promote our weight. Attribute promote. Now, try this again. Tab, attribute promote. And we're going to grab our weight. I'm going to go from this to primitive. Okay. The next thing we're going to do is we're not going to blow up. We're going to isolate a section of these and make sure we're on primitives. So we're going to say if the weight is greater than a certain threshold, I like using T for threshold, then we're going to put us in a group at active, at group active equals 1. Okay? Click this little button here to make that channel. I like my channels being on top because I'm a tablet user and I hate scrolling down to go find these. So I'm going to take this bad boy and put it at the top. And also I know that my weight range goes up to 2, so I'm going to just put this at 2 for now. Apply, accept. Okay, and if I turn this up, we should see that there are 185 active primitives, active constraints in the active group. Good way of checking that, it's always good to check. Make sure what you're thinking is what you expect. At active equals 1. So these are the ones we're going to blow up. They're primitives. Oh, actually I don't have to do at 1. I can just do what is the active group, right? And these are the ones we're going to get rid of, right? These are the ones that are going to be gone. So we're going to group copy these over, copy. So here it goes. We're going to group copy, and we should be able to see active here, active. And then wrangle, we'll use the primitive wrangle. Make sure it says primitive. And if you're active, we are going to put you at group into the broken group equals 1. And if we look, okay, there we go. We should see that we have some in active and some in broken. Now we're going to make sure that we get rid of attribute group, the active group, since we don't really need it anymore. We're going to get rid of active, so that doesn't exist. And we'll output this. And now what we're expecting is we're expecting our building to blow up, and it should really blow up. So let's go up. Again, we've done a lot of work, so we're going to save. And we're going to go back to frame 1. And let's give it a run. Boom! Oh, where'd the pieces go? Boy, they really took off. So let's take another look here. This was pretty intense. So let's go down to 2. And let's make sure our gravity is at 100, right? And let's go up and look at what our RBD fracture was. So we made some constraints. Our constraints are really strong. So let's try something like 100. Let's go in here and rewind. Boom. Now, I was sort of expecting our constraints. Maybe the way to do this is these constraints, we're going to redo our constraints just a little bit here, right? So one thing we can do is come off of here, null, and we will go, these are all of our pieces, we'll unpack, we unpack this, and we keep our name. So we should have name. Okay, so we'll go here, delete. Oops. Go here, and we should be able to do adjacent tab, connect adjacent pieces. And that should give us, and we'll do from surface points, right? And now, I think we can do RVD constraint properties. Plug this into here, and we'll go 100. We'll go something like 10. And this is the propagation rate, so propagation duration. So let's go 3, and we're going to put that into here. And now let's see what happens with our boom. I was expecting a little bit more from that. So let's give it a little bit more strength. Boom, there we go. Now we're really busting it. So let's go 3 and see what happens. Boom, and that's what we're kind of expecting. Our building to get a little explosion and go. Maybe I made my constraints a little bit too weak. Let's go back up to 20. Now it's just really about dialing in values, right, to kind of get the look that we're looking for. So boom, some of them stick together. Some of them break apart. The great thing about this is now we can have a lot of art direction, right? So we could always merge in another metaball. So if we take this same concept, copy and paste this over, and instead of this, we'll do frame 8, right? Plug this in, and let's just move the metaball. Let's move it up here to, maybe this back corner. Now, instead of just blowing out, right? So we can blow out, but we can also define which way we want to blow. So let's say that we want to blow things up just in Y, and blow things, we're going to really shoot stuff up in Y. We'll get rid of this directional force. You'll notice what we should see here is, and we'll make it a little bit bigger. We'll blow up this whole column here. What we should see is this whole thing shooting straight up. Let's see if that's the case. So it's going to look at this direction, and it's going to blow it up in that direction. Let's see. Boom. Well, it didn't blow it up very fast, did it? So on frame 8, is that what happened? Frame 8, it seemed to just fall over. So let's really crank this up. Oh, axial force. How much of an axial force? This is what we have to do. How much are we going to go this route, right? I forgot to put in that number. So this was the important number here, axial force, along the axis, right? Let's make sure we hit resim. Sometimes when we change things on the outside of these sims, they don't know that they've been resimmed. Boom! There you go. So you can see we can start really art directing the way we want things to go. Not only can we go up, but we can actually go rotate around. So maybe not so much up, but a lot around. So let's see what happens if we rotate around. Vortex will be around the y-axis, around this axis, which would be straight up. So again, we change something on the outside. We probably just, don't be frustrated by this. Just hit reset sim. And what we should see is, boom, see it rotated around. And we can do that. And the great thing about this is, if we look at this force, right now we have a force that's going straight up and down. It will respect transformation. So here I have a little expression that says center my pivot. So centroid inside of the pivot. So I'm going to rotate my force so that, and I'll put it somewhere like this. And what we'll see, go in, is let's really push around. We'll go something like, we'll go 4 times bigger. And we'll go a little bit more out too. And let's see what this does to the sim. Now remember, we're just going to hit the reset sim button. Reset sim. And here we go. Boom, a little twisting action, right? So Metaballs are a really great way of kind of art directing ways in which you want to blow stuff up. Now, This might be a little bit more interesting if we really throw some pieces at it. So 100. Primary fracture, we're going to go 444. See how bad this is for my old Mac. Okay, it's definitely I'm thinking now. Okay, now it's done. Created a whole bunch of pieces. Probably going to turn this force down. Now, one thing about centrifugal force is we might need to actually suck that force in. So a spiral force is towards the vector. And if we look again, we've got this guy here. Make this a little bit more along an axis here. Turn, rotate, and we'll rotate this guy a little bit more towards axis. T, maybe move him over here in the middle a little bit. Okay, so we're gonna look at this guy again, and we'll add the spiral force and see what that does. Turn this down to 2 maybe, and give this all. Remember, we're gonna click here. It should do a whole new recent because we have all these new pieces. We have our bomb going off on the back, and then boom! Look at that nice little spiral kind of ripping apart this building. So this is a great use of using Metaballs to kind of just, art direct RBD systems. You could do the same thing with grains, anything else. Okay, let's get on to the next section.